So we're given some information. We're given that triangle ABC is isosceles. We're given that the base is AC. We're given that BD, the line segment, bisects the angle B. And they want us to prove that angle BDA is congruent to BDC. So they want me to prove that this angle equals this angle. And so the first step when you're doing a proof is you make a little table and you say statement, usually more than one, so you put statements, and then what are the reasons? Why is that true? Now, just like in English class, you're going to have an introduction, a body, and a conclusion. Your introduction is always the given. So you're going to copy this part now. And what's the reason? It's a given. So I'm going to copy that part down. Now I would go ahead and copy down the conclusion at the bottom, but I'm not quite sure how many lines I'm going to need. So I need to start making markings. And so if I could show that this triangle is congruent to this triangle, then that also shows me that certain angles are congruent. So we'll start with the first one. It says that triangle ABC is isosceles. So which one is that? Well, there's three triangles. There's the first one, the second one, and the large one. So ABC would be the whole thing. Okay? And it says that this is the base. So if this is the base, then that means that this is congruent to this. So how would I write that down? I just saw that AB is congruent to CB. How do I know that? Well, there's many ways you could write this down. There's not just one way, but pretty much you're just going to say, because that's what an isosceles triangle is. Okay? If you have an isosceles triangle, you have two sides congruent. We know that those two sides are congruent. Why? Because they're isosceles. So there's many ways to write this, but you could just say, by definition of isosceles triangle, so there's more than one way to put that. The next thing I see from the given is that the segment BD, that would be this segment right here, that it bisects angle B. Well, here's angle B. And so what does it mean to bisect? Bisect means cut in half. So they're saying that BD cuts this angle in half. Well, if you cut something in half, then it's going to be congruent. So now I know that this is congruent to this. So that'd be my step 4. The angle ABD is congruent to angle CBD. And I left off my angle symbol. So I know that you can't just say angle B is congruent to angle B, because then I don't know which B you're talking about. So when you're naming angles, you should use 3 letters if you have to. Now, how do I know that's true? Well, no, that's true because BD bisects angle B. So to sound fancy, I'm just going to say by definition of, and there's many ways to write this, of bisecting. Alright, so to use my congruence theorems, I need to have 3 pieces of information. And this one, you're going to see again, I promise you. And what this one is that BD is congruent to BD. How do I know that? Well, they share the same side. So I'm going to say BD is congruent to BD. And instead of saying that, there's actually a property in math. It's called the reflexive property. So if you look at yourself in the mirror, you see the same thing back, kind of the same idea. So I'm going to say reflexive property. And then from there, I know by the SAS that these triangles are congruent. So I'll say step 6, that triangle ABD is congruent to triangle CBD. How do I know that? Well, I use the SAS. And if you want to look to see if it's a postulator theorem, you can. To me, that's not as important. Some teachers do care about that. Now, usually that's the last line. Usually they just want you to prove congruency. But they want us to prove, so think about it. We just proved that this triangle is congruent to this triangle. So that means that angle A is congruent to angle C. That this angle is congruent to this angle. That means that angle B is congruent to angle B. So this angle is congruent to this angle. And that also means that angle D is congruent to angle D. So right here is congruent to right there, which is what they want me to prove. So I'm going to say, my last line is going to be my proof, that angle BDA, which is this one, BDA, is congruent to angle BDC. BDC is this one. And how do I know that? There's many ways to put it. I would probably put the CPCTC. And all the CPCTC says is that if the triangles are congruent, then the corresponding angles are congruent, the corresponding sides are congruent. We know they're congruent by the SAS, so we also know that the angles are congruent. So reading this, I know that the segment BD is perpendicular to the segment AC. And then I also know that D is the midpoint of AC. And they want me to prove that this side, AB, is congruent to this side. So I'm going to start off with my given. So I'm just going to copy down. And the reason why is the given. So first, BD is congruent to AC. So BD is congruent to AC. So what that means is this is 90 degrees, that's 90 degrees. So what I could say is that angle ADC is equal to 90 degrees, which is equal to angle BDC. How do I know that? Well, that's what it means to be perpendicular. And you could almost say this in one line if you wanted to. Some people separate these in two lines. But on the same account, if they're both equal to 90, so that means that they're equal to each other. So now you can say that angle ADC is congruent to angle BDC. Why? Because they both equal 90. And there might be a more fancy way of saying that, but that's all I could think of right now. So again, you could probably almost put that in one step. So now what we have is that they're both 90, but they're also both congruent. So this equals this, and that's how I get my A in my formula. I also know that D is the midpoint of AC. So D is in the middle of AC. That means that this equals that. So that means that AB is congruent, and actually that's D, I'm sorry, I should say D. AD is congruent to CD. How do I know that? Well, if D is in the middle, which is called the midpoint, then those have to be equal. So I might say definition of midpoint. And then finally, use this property a lot in proofs. And it basically just says, just like before, that BD is equal to BD. Why? Because it's reflexive. And so I have to decide, do I have enough information to prove these triangles congruent? Yes, I do. I have S, A, S. So I would say that triangle ABD is congruent to triangle, and I start in the same spot, so I start at C, CBD. How do I know that? Well, by the S angle side. So that'd be by the SAS. And then finally, so if we know these triangles are congruent, then that means the corresponding angles are congruent. So angle A equals angle C, angle B equals angle B, angle D equals angle D. And that also means that the segments, so that means that AB is congruent to BC, which is what they want me to prove. And how do I know that? That'd be the CP CTC. So that is the full proof right there. I did exactly what they want to say. Like I said, usually the last line is proving the triangles are congruent. That's usually what they ask you to do. But alright, this whole page is review. So, what angles are congruent to angle 3 and why? So let me mark angle 3. It's right here. So I'm going to first say that angle 3 is congruent to angle 2. So these are congruent. How do I know that? Those are called vertical angles. I also know that angle 3 is congruent to angle 7. Why I'm using a huge pen. Angle 3 is congruent to angle 7. How do I know that? They're corresponding. And then I know that angle 3 is congruent to angle 6. How are 3 and 6 related? Those are alternate interior. So when you have two parallel lines cut by a transversal, you're going to have congruent angles. There's going to be 4 of them congruent. Right? So make sure you have that vocab still in your head for the test. Here, I'll go through this part pretty fast. This is what we call a line. So this is a line because it goes in both directions. Now if I'm going to name this, I would call this MN. And remember, you put an arrow on top to show that it's a line. This is what we call a ray. And if I'm going to name it, I go ST. And because S is the endpoint going this way forever, That's what it does here. Notice the arrow does not go this way. And then this is called a line segment, or just sometimes segment. So you put UV just like that. That means line segment. Here are the lines parallel. This symbol means parallel. That means they never touch. Intersecting means they just touch. Perpendicular means they touch and at a 90-degree angle. So this one would be perpendicular. But these are just intersecting. They cross. Finally, review of segments, segment addition. It says B is the midpoint. So it's saying that B is right in the middle. If it's right in the middle, then by definition of midpoint, 2x minus 8 equals x plus 17. I pull out my algebra from last year. I solve this. I go minus x, which is one way. There's many ways to solve this. And I get x minus 8 is 17. And then I add 8 to both sides. And I get 25. So what is x? X is 25. Be careful. You don't always ask x. And then let's fill in the rest. AB would be 2 times 25 minus 8. 2 times 25 minus 8, that's 50 minus 8, which would be 42. BC would be 25 plus 17. 25 plus 17 is 42. These should be the same because they're midpoints. B is in the midpoint, so those should be the same. Now what would the whole thing be? So what is 42 plus 42? That is 84.